Alright, so first ever project of the channel is I was looking at flight tests a while back and they were chucking around a little circle plane with a rubber band, and I thought that was really cool. I was also watching their penny planes video at the time, so I kind of want to do something similar to that. So I start out by researching some rubber band powered planes just to see if there are any cool and innovative ideas or what people generally go for in this sort of type of thing. And I'll take a look at some images. I mean, there's a couple of cool two-wing designs, a couple of monoplane designs. I've noticed the prop on a lot of these are quite cartoon-esque, if you will, for the type of scale of the aircraft that are and about. But they generally tend to follow a similar sort of design with a large motor stick and a cartoony prop with some very light wings on. So let's start designing something. Okay, so first idea I had was some sort of Apollo Regalo wing type design, which I thought would be quite cool. Have a look at Vintage Space, who did a wonderful little documentary on the actual proposed landing techniques of the Apollo capsule before they decided to do parachutes, and Regalo wings were actually a really cool design. I used to make some back in the day for school and whatnot. They're a couple of simple triangle bits of paper and 3 or 4 sticks together, and you actually make yourself a really efficient little glider, so it's a fantastic design. I also went for a more sort of traditional motor stick design, very simple, just, you know, big old lump of plastic maybe. I want to 3D print this, but I think I can do a bit better. Then of course there's the Wright Brothers type of design, which is actually a really cool design because you've got the wings actually provide a lot of the structural support for the actual plane itself. You can cross brace it with some high strength cording as well. You can get some really nice light and strong thread, which would be really cool to use. Plus you can get probably 2 props out of it. 2 rubber bands, maybe twice the duration, big wingspan, a lot of lifting surface, which are really cool design. Then I was thinking more of a truss design, I think, you know, like cranes and bridges and things like that. That could work. Maybe even an ornithopter. But I settled in as a sort of a hybrid truss motor stick design that's sort of similar to how you'd normally see in these rubber band power planes, but we start modelling up the actual truss design with just a simple sort of zigzag and the actual bearing part of the motor stick protruding down below the unit, so we've got plenty of space to have an actual rubber band. I was thinking about putting the rubber band inside the actual fuselage itself, but for now, I wanted to keep it kind of simple. There you go, just fix up the tail. Now I wanted to add this little hook on the back so we can hook the rubber band over, and a little hole in the front so you got a nice bush and we can have a little rotating prop shaft there. And there we go, it's time to 3D print it. Trusty Wanhao duplicator. It's never failed me yet. Well, until it breaks, which it sometimes does, but it's not that hard to fix. Look at that, it's done a fantastic job on the print. Okay, now we want to work on the propeller. And I was thinking, starting about doing some prop nuts. This is, I think, the best way I could think about making it, which is sort of have this wedge cutout piece in the actual hub, and I was thinking of sandwiching a piece of plastic in between these 2 angled plates here, add a bit of a transition so we don't have to bend or cut the plastic too much, and we'll add the other mirror image of it, cut it out there, just so we've got some 2 halves of our prop nut that'll sandwich some nice recycled bit of plastic in there to give us a lovely lightweight propeller. And I'll add a bit of a nose cone to it, just because I can in this software. It's incredibly easy to make complex designs like this, especially with designing and printing CAD/CAM software. It's fantastic. So there we go, couple of little prop nuts. They only take 3 minutes to print too, which is lovely. Now we want to design some props. I'm designing them here and I will 3D print them, but that's just so I can have a bit of a template blank. So I can actually cut out the plastic in a nice symmetric format without folding, bending, or doing anything nasty to the actual plastic. It's all nice and clean. The computer's way more accurate than I am, so if I can use it, I will. I copied and pasted the design a couple of times and changed it up, just because I was kind of shooting in the dark with the actual dimensions of the prop itself. I didn't really know how big or how thick to do the blades. I mean, I know it's the bigger the surface area, the less slower the props are going to spin, but the more air it kind of moves. There's some complex math behind it, which I'd love to do some research on. There's some on the Penny Planes forum. Very good designs on there. But for now, I just did a fat one, a thin one, and a little one. I think I ended up going with a little one, just for now, but we'll see. This is the little mod I needed to do. I had a great bit of inspiration, but I added those little tabs on there, just so we could fix this nice box wing that I'm designing up here. Lovely thin box wing. This is the wonderful thing about printing like this, is you can get these lovely little thin box wing designs, and hopefully that'll fit onto those little clips there. So for the next step, I'm going to take the wing and the tail section, which is this little V thing, and we're going to take some bin bag, or as I like to call it, thin bag. The really cheap, the cheapest bin bags you can possibly buy work the best for this, because they're the thinnest, they're the lightest, they're just the best. And sometimes they can even react with a little bit of heat, so if you get a wrinkle or two in them, you can just hit them with a hairdryer like heat shrink, and it just sort of pulls them tighter again. A lot like the actual skinning of real RC aircraft, which is quite nice, but this is done on the real cheap. I would like to actually make a proper penny plane like this and properly skin it with some actual material and see how well I can skin it up. So we want to hold this out nice and firm, so I grab a couple of magnets just to hold it nice and secure, and we'll use some cyanoacrylate CA glue. Just run it all the way around the rim there. You probably don't have to use quite as much as I have, but as long as you get a nice good solid contact and the bin bag stays kind of tight. You want to cut off enough for the tail and for the wing itself. And once it's dry, you can just use a scalpel or an X-Acto knife just to cut out the wing nice and steady. And this I found is a really cool method of actually designing and skinning the wing. Like I say, we'll bend the aerofoil into it, and that will also pull that a little bit tighter and smoother, but like I say, it doesn't have to be baby smooth drum tight. It just needs to be, you know, flattish, like I've got it. There we go. There's a finished wing, and I also did the tail as well. Now we move on to the prop. So this is a little thin bit of plastic I dug out of recycling. It's just a nice big flat bit of plastic. And there's our little prop blank. We just pop a pin through the center of the prop blank. I added a little hole in there so you can find the center of it nice and easy. Now we just use that template to cut out our propeller. And this should give us a reasonably accurate, nice looking propeller at the end of it. I also kind of like the see-through plastic as well, because it kind of looks like there isn't a propeller there sometimes, but I mean, I'm sure if you've got your own plastic, you can use whatever colour you like. I actually lost the footage of me assembling the final prop, so here it is, all fully assembled with the prop nuts and everything. The SD card kind of bugged out, so sorry about that. This is now moving on to the bending of the aerofoil itself. I just used a container like that, and a couple of rubber bands to hold it over, and then hit it with the hairdryer. One to tauten up the skin of it, and two, because the PLA softens up with a bit of heat, and then when it cools down it maintains its shape, so you can add a nice little aerofoil to it. And that will lock into those little tabs there. And that'll be a nice little aerofoil design, all locked up in place. We'll add some strengthening with this cotton string, and we'll just stitch them together. It's alright if you put a couple of little holes just either side of the fuselage through the skin of the plane. It shouldn't matter too much. I like to poke it going top down. Again, the actual wing holds the plastic rigid, whereas if you poke up it might pull off the wing itself. You can do about 10 turns of that. Wrap it up and make sure it's nice and tight. Do it on the front and back, and you should have a nice secure, sturdy connection. I also like to add a little dab of CA glue too. And that's our wing all secure in place. Now let's move on to the tail. For this guy, I found the best solution is this steel wire here, the 1mm steel wire, which we'll use for the prop shaft as well. This is just bent simply into a U shape and put through the little tail hook there for the rubber band. There's a couple of holes already pre-printed up in the actual tail design itself, but I don't want to use the cotton itself, just because that's only got one anchor point and it's kind of flimsy, whereas the wing itself is got two anchor points spaced out quite wide, so it keeps it relatively strong and stable. We'll just drop that down there. Keeps it nice and strong. We'll make it the strongest connection it can be without the glue, but we'll add a little dab of glue extra. But yeah, this is a really nice way because you can grab it with the pliers, as I'll do in a minute, squeeze them together and really get it nice, strong and secure without actually using any glue. And then the glue is just an insurance policy. I mean, these things sort of tear themselves apart if you crash them really hard anyway, so... But it helps. I mean, you could always print another one, that's why they're printed, right? And then I just bend each side down, just to make that finally nice, flat, flush and stable. At least something you won't stab yourself on either, because you might hurt your hands with the sharp edges. Cut that nice, flat and flush there. Minimise all the weight, so that's held on nicely. And like I say, here's our insurance policy of a little dab of CA glue. Also just stops it side to side. These wings also come with a bit of adjustability because you can kind of bend that back tail up and down if you find it's a bit nose heavy or tail heavy. You just adjust the trim of it. If you do also find it bends over to the left or the right, I would like to add a bit more dihedral or polyhedral to the wings to prevent it from, say, bending left or right. But if you want, you can just bend up one of the sides of the tail a little bit left or a little bit right, and it kind of adds elevons. So this is the 1mm by 2mm tube, 2mm outside diameter, 1mm inside diameter, which fits that. 1mm wire, steel wire that I've got. Here I'm using a file to cut it in half. It's only aluminium, so it takes 30 seconds to do so. But I'm cutting it rather than nipping it with those pliers because they end up sort of crushing it with the shearing blades, the shearing teeth, and end up actually crushing the walls and losing that nice 1mm hole. Whereas the filing is more of an abrasive action, which preserves the actual shape of it and just cuts away minimal amounts each time. And there you go, after just filing it down so it's nice and square. We created a lovely little bushing for our propeller to spin freely in. Nice metal on metal, has a low coefficient of friction too, so hopefully we'll get plenty of power out of that propeller. Here it's generally a good idea to scuff up the actual tube itself. You do this when like painting Nerf guns and things to help the glue and the paint stick in all the cracks and the valleys. The 3D print actually has a lot of layer lines and textures in it itself, so that'll stick really nicely with the CA glue. It doesn't matter if a little bit sticks out either end. In fact, it's probably a little bit better just so that the prop's not rubbing totally against the plastic housing. It's more rubbing on the metal, which is much tougher and hopefully give you more life out of the actual propeller itself. Okay, at this point I've seen people use a little plastic or ceramic bead just to space the prop away from the actual hub here. I didn't have that, but I used a bit of the tube itself, and the tube is quite nice because I can customize the length and have it as long or as short as I need to. Plus it all fits nicely. So just a length of that, and that can be glued to the prop itself. That doesn't need to spin, it's just more of a spacer, if you will. And that fits neatly on there. So we've got some aluminium on aluminium friction there, which is, again, a nice low coefficient. So we get plenty of power and speed out of it. Now we want to bend a hook so we can wrap a rubber band round. I want this to be a bit of a chuck glider slash rubber band powered launcher, however you want to use it. So you've got the option to do either. So this is a nice little, nothing fancy, just a straight square hook would do. You don't have to bend anything neat and round. As long as it grabs the rubber band, it should be fine. There we go. And I want to flatten the hook out as well, just to keep everything nice and concentric and square. We don't want anything wobbling unnecessarily. There we go, I think that's pretty much the planes all finished up. You can string some rubber between the hook and, well, the two hooks. It should just go over the actual wing itself, and it's time for our flight test chuck test. Those little things work really well. I mean, it flies, certainly. It certainly does its job, and it does it very well. I mean, don't get me wrong, I think it could do with a lot of design improvement to make a bigger wingspan or something, but as a little prototype glider or a quote-unquote toy, it works very well. I really like it. Maybe if I send this off to the guys at Flight Test, maybe they'll give me a few pointers on here and there on how this will work, and how I could do it better. As I say, I'm not an aerospace engineer, so I wouldn't really know. As we can see here, I mean, I've had a bit of a flight test, but unfortunately she's ripped the wing out a little bit. So, you know, not ideal. I mean, these guys are kind of delicate anyway. I managed to 3D print a little spar thing just to hold them out for my own testing. I mean, like I say, they're not the strongest in the world, but they'll certainly fly, at least for this. But yeah, tune in next episode when we can use the launcher and things. We'll make the launcher for it. And also I've got a few extra plans for the Regala wing design and even the ornithopter. We'll make that video and have fun making it, because I had fun designing it.